Hi, I am Napoleon A. Gacking Jr. Welcome to this channel, Tough Math. This channel features solutions to some math competition problems given in the past several years here and abroad. So if you are new to this channel, welcome. And I hope that you will enjoy our discussion for this video. So our problem for today is find the total number of ways of expressing 270 as a sum of consecutive positive integers. Okay, so first we look at the prime factors of 270. 270 is 1 times 2 times 3 cubed times 5. Okay. Now, 270 is expressible as a sum of consecutive positive integers if, okay, number one, n is odd as a sum of n. There should be n there. Okay, 270 is expressible as a sum of n consecutive positive integers if n is odd and 270 divided by n is an integer, meaning 270 is divisible by n. And then 2, when n is even, then 270 divided by n must be an integer plus 1/2, whatever this integer is. Okay, so for some in positive integer n. Okay, so we consider the following cases. The odd numbers 3, 5, 9, and 15 divides 270. Okay, so 270 is divisible by the odd numbers 3, 5, 9, and 15. Hence, 270 is expressible as a sum of 3 or 5 or 9 or 15 consecutive positive integers. Actually, 270 is also divisible by 45. It's also divisible by 27. However, we will not include these cases because for these cases, the sum would include negative integers. And since our requirement is that integers, the consecutive integers, must all be positive, so we do not include these cases. Okay. And by the way, I would like to add that in case 1, where n is odd and n divides 270, this quantity 270 over n is actually the middle summand. So, for example, in the case of 3 summands here, this one here, the middle term is 270 divided by 3 is 90. So this is 90, and then plus 91, and then on the left side you have plus 89, and this is equal to 270. In the case where there are 5 consecutive positive summands, there are 270 divided by 5 is 54. So the middle term is 54. And since there are 5, then you have a 55 here. I would change the color for emphasis or highlighting. So this is there is a 55 and a 56 on the right side, while there is a 53 and a 52 on the left side, and this totals 270 also. So the same thing is true with 9 consecutive positive integers. There would be 30 because 270 divided by 9 is 30. So there would be 30 consecutive, no. There would be 9 consecutive positive integers, and 30 is the middle summand. Okay. So, another case, I will use this black color. 270 is also, I already made a comment about this, but then anyway, I would just like to write it down. 270 is also divisible by 27, 45, and even 135, but the corresponding sum, or sums, for these 3 include negative integers. So we do not include them in our list of ways of writing 270 as a sum of consecutive integers. 270 is not divisible by by 7, by 11, by 13, by 17, by 19, by 21, by 23, 25, and so on. Or 27 divides 7 to 70, but as I mentioned earlier, the sum would include negative, so negative integers, so we do not include them, etc. So no such expression of 270 as a sum of consecutive integers exists. So no such expression exists. Now let us go to the even. For the even, we have 270 divided by 4 equals 135 divided by 2, which is 67.5. Then 270 divided by 12. Yes, 12. First, we divide it by 2, so you have 135, so we have 6. And then we divide it by 3, so you have 45, so you have 2. So this is 22.5. And then 270 divided by 27, this is no 20. Sorry. $270 divided by 20. This is equal to 27 over 2, which is equal to 13.5. And so therefore there, hence 270 is expressible as a sum of 4 or 12 or 20 consecutive positive integers. And I would like to add that because they are expressible, then here, when n is even and this condition, the second condition, is satisfied, 270 divided by n is actually the average of the two middle summands. Okay, middle summands, meaning here we have a 67 on the left side and a 68 on the right side, and then plus 69 and plus 66 on the left, then we have 270. Okay, and for 270 over 12, the two middle summands are 22, and of course the other one is 23 because they are consecutive. And this one here, the two middle summands are 13 and 14. And since there are 20, therefore there are 9 consecutive integers after 14, and 9 consecutive positive integers before 13. Okay. Now, for the other even positive integers, no such expression is possible. Okay. So, therefore, (270) is expressible as a sum of 4 plus 3 equals 7 consecutive positive integers. The 4 is for the odd case and the 3 is for the even case. This one is for the odd case or odd n, and this one is for the even n. So next we go to our second problem, B. The set S is a subset of M, which is equal to 1, 2, 3, and so on up to 2023 and then 2024. Such that at least 2 elements of S such that S contains 2 elements whose difference is divisible by 17. At least how many elements? does S have to guarantee this condition? Okay, so the set S, which is a subset of M, which contains the numbers from 1 to 2024, is such that it contains is such that it contains two elements whose difference is divisible by 17. At least how many elements does S have to guarantee this condition? Or to guarantee that this condition holds? To guarantee that this condition holds. Okay, now any integer x is of the form seventeen k plus r, where r is equal to 0, any one of these numbers, 0 to 16, and k is an integer. So let T be the set containing x sub 1, x sub 2, x sub 3, and so on up to x sub 17, such that such that 17 such that whenever I is not equal to j, then 17 does not divide xi minus j. Okay. So T is not S because T does not satisfy the given condition. Okay. Now, let x sub p be an element of M but not of T. Then x sub p, being an integer, is also of the same form as the others. So it is also equal to 17 times maybe q plus some t, where q is an integer. Okay. However, there must be xj element of t such that xj is equal to 17k plus t. Then xj minus xp is equal to 17k plus t minus 17q plus t, which is equal to 17k minus q. That is 17 divides xi minus x sub p. So therefore t union x sub p must be a subset of S, which implies that S contains at least 18 elements of M. Okay, so that's it for this video. So, but before we end this video, as I have been doing in the past several videos, I leave you this challenge. The positive integers a, b, c, d satisfy the equation 1 over a minus 1 over b plus 1 over c minus 1 over d equals 1 over 42. Find one possible value of a, b, c, d. So I challenge you, or challenge yourself, to solve this problem before viewing the solution, which will be given in the next video. And also, I leave you this food for thought, or something to think about. Character is much easier kept than recovered. This is according to Thomas Paine, a British-American thinker. So that's it for now. I hope you learned something new and you enjoyed our discussion. So goodbye for now, and may God bless you all.